Alright, let's solve today's Leetcode challenge question, which is perform string shifts. So we have a given string S containing lowercase English letters. It doesn't matter. We have a matrix called shift, where each row is a shift operation. It consists of direction and amount. The direction can be either left or right. That's the order. That's the direction we apply these shifts. And the amount is the number of characters we apply a shift on. So a left shift by 1 means that we move the leftmost character towards the end, which is the right, and the right shift by 1 means that we move the rightmost character and put it towards the leftmost. So you can see that the left shift and the right shift, if they are the same amount, then they cancel each other. The string will be unchanged if we cancel the left and the right shift. So example, we have ABC. We do 1 left shift and 2 right shift. So we'll actually cancel one of the right shift with this first left shift. So the result is equivalent to just 1 right shift. So that's moving the C towards the beginning, so we get CAB. If we can just look into the shift matrix and figure out, consolidate all the shifts, we only need to do 1 such shift. That could save a lot of time. So you don't really worry about all the intermediate result. So the second example, we have A, B, C, D, E, F, G. We have 4 shifts here. We notice that the first 3 actually cancel, so it's equivalent to do just 1 last shift here, which is do right shift by 3 times. So we pick G, move it before A, and F before G, E before F, so we get E, F, G, A, B, C, D. So that's pretty much the question. So the strategy is to try to solve it smartly by looking into all the shifts and just consolidate them into 1 big shift, and after that we should be done. There are some properties of these shifts here. In this example it doesn't show you, but what if we shift in we have a number of shifts, amount of shifts that's larger than the length of the string, and if there are any kind of relationship between shift left and shift right. If we first look into those, you could make the code even more simpler. So let's look at that. Let's say that the string is ABCD. If we do left shift by 1 location, we get B, C, D, A. If we do right shift by the complement kind of amount, so this is the length 4, right? So 1 and 3 they add up to 4, and the direction are opposite. So if we do this right shift by 3, what do we will get? It's D, A, B, C, and C, D, A, B, B, C, D, A. So we end up with the same result. So this tells you that if we shift in the opposite direction by a complement kind of amount, we can also cancel each other. And yet another one is what if we shift by 4 location? So let's say that we shift right by 4. We just keep doing 1 more rotation, we get A, B, C, D. So it's unchanged. So if we have a shift that's larger than the length of the string, what would happen? So this is equivalent to this. You notice that the shifts here are sort of like additive. So this is equal to 1, 3, then 1, 4, then 1, 3. Since 1, 4 is it's basically leaving the string unchanged, it's equivalent to 1, 3, which we know the result is this. So if we have a shift that's longer than the length of the string, it's equivalent to do just the modular. So with this, we can start coding. I'm just gonna stick with Python today. Alright, so let's code. Okay. So we're gonna consolidate all the moves into a right shift in the end. So initially it's 0, and we grab the length of the string. So we go through all the shifts in here to consolidate them together for direction and amount. We will basically just do if the move is right shift, then we increment this right shift by the modular of the amount and the length. Sorry. Otherwise, we also increment, but in the opposite direction. So the negative number modular is going to be the basically be the complement. So if it's in the opposite, if we actually need to move in the opposite direction, it's using this complement property here. So with this logic, we pretty much end up with a final right shift we need to do to transform the string from the beginning, from the initial inputs to the final result. So basically just return let's for the sake of I'm not sure if we need this, but we can just make sure that we are doing the minimum number of a shift. So if we add something that's then we go having one more loop. We're gonna do a modular to make sure that we need to do the amount of shift we need to do is minimized. So yeah, so that's pretty much it. We can just do string slice here. So since we are looking at the right shift, we move the end towards the beginning. So that's by this kind of amount, by right shift amount. So yeah, this should be the code. The time complexity is order of it's linear in the shift and the string add together. So if we have m to be the length of string and l to be n to be the number of rows in the shift, it would just be linear with those two added together. And for the space complexity, this will create a copy. So it's both this will create a physical copy of the string. So it will be linear with respect to the length of the string. But if we have string builder, we still have to collect all the characters. So I guess the space is going to be linear with respect to the input string. So that's pretty much it. Let me try to submit to see if it works. Okay, okay, it works. Yeah, so hopefully this I did not mess up the explanation. Okay.